Manager, WaterSMART Solutions, and we at WaterSMART have partnered with CRIN and the CRIN Water Theme to put on this webinar. So yeah, thanks everyone for joining us. We're looking forward to a great discussion. We have a panel and some great speakers, and really what we're trying to do here is help build connections within the water innovation ecosystem, and bring people together and help each other, or help you guys find each other and go off and innovate. Before we dive in, I do want to take this opportunity, just in the spirit of respect, reconciliation, and truth, to acknowledge that we all live, work, and play on Indigenous traditional lands. And I know this is a virtual event, of course, so people are tuning in from across Canada, but myself and many of us here are joining from the traditional territories of the Blackfoot Confederacy, including the Siksika, the Kainai, and the Piikani, and the Treaty 7 nations comprised of the Tsuut'ina and the Stoney Nakoda, which includes the Wesley, the Chiniki, and the Bearspaw, and Métis Nation, Métis Region number 3, and all other Indigenous people who make their homes in southern Alberta. And we at CRIN, we encourage you to research what Indigenous traditional land you are situated on and consider making or finding your own land acknowledgement to use. So with that, let's jump in. Just a couple quick housekeeping pieces today. As you've all seen by now, I think the webinar is being recorded. So if you have to step out, or if one of your colleagues has missed it or something like that, we'll have access to that recording later on. So that's a good reference. And we'll just ask that everyone stay on mute for the duration of the webinar. We'll have quite a few speakers to go through, so we want to make sure everyone has a chance to hear what's being shared. That being said, we do really want you to ask questions. So we have the chat feature in this Zoom platform, so I'll be monitoring that chat. And if you have questions for the presenters as things go, please just enter your question in the chat. And if you can note who the question is for, that will help me direct it to the right person. But yeah, throw those questions in the chat, and after each speaker, we'll have a brief period for questions, and then we may have some time at the end for broader questions as well, depending on how things go. So yeah, we do want to hear from you guys with your questions. In terms of the plan for today, we have a panel right after this, or a quick opening. So that will be a great discussion to kind of set the tone and set the context for what we're talking about in terms of innovation in the water space, and what that means and what that looks like. And then we have 4 great speakers who are kind of going to be sharing case studies of their experience with innovation, with specifically around electrochemical water treatment processes for various applications. And then we'll have a bit of a close and wrap up. So that's the plan for today. I'm going to pass things off to Adele Zenade from Canadian Natural, who's the co-chair of the water theme with CRIN, and she'll do a brief intro to CRIN and what we're all about at the water theme. So Adele, over to you.
Thanks, Steve. Good morning, everyone, and good afternoon, depending on where you're calling from. I co-chair the CRIN water theme alongside Mick McGregor at Suncor. And for those of you who are not familiar with CRIN, we are a vast network of networks across Canada that really aims to make connections between challenge owners and solution providers. And as you know, there's many nodes in this network when it comes to innovation and our ecosystem. So our job is to engage with folks across Canada and different industries to try and find solutions for the oil and gas sector. So today is one example of those activities in which we hope to engage with you, hear your ideas, have you get answers to your questions, and meet people that you can collaborate with. So our network is quite large. We have a membership of over 3,000 members and growing. And we have 19 sectors that are a part of CRIN. And we currently have 7 technology theme areas. And don't be afraid of the fact that it's technology. We aim to include folks from different sectors within that. So it's not all just strictly technical. And really what we do share is a passion for innovation with a common goal of leading the global transformation to a cleaner energy future to ensure Canada's long-term prosperity. And you can think of CRIN as an amplifier. There's a lot of organizations in the ecosystem, as I mentioned, and really we are trying to be the and in the conversation about energy in Canada when it comes to changing that narrative, you know, between choosing one energy source over another. Really, it's about working together, complementing each other, and accelerating technology adoption. And within the water theme, we've been quite active since 2018, and we have had numerous workshops, steering committee sessions, conferences, webinars such as this event today, and we connect through various avenues. One of the best ways to connect with the water theme, if you're not already, is to join our LinkedIn page. And typically, once you go to the CRIN website and you join CRIN as a network, which is free of cost, you'll see links to the areas that you're interested in. And really where the connections take place or can begin is through our LinkedIn group. So you'll see in the chat a link shared to our group, but also at the end of this presentation, you will find the links that I mentioned here. So really, we're here to make connections in the water space, find solutions, and work together to move things forward at a faster pace. So I really hope you enjoy what we've put together today. And I will now pass it over to Steve to introduce our speakers and to moderate our panel.
Great, thanks, Adele. And really great introduction for what the CRIN water theme is all about. So let's move on to the panel discussion, and I'm going to welcome our panelists. We have Kevin Frankowski, who is the Executive Director at Aqua, and JC Bourgeois, a water treatment engineer at Canadian Natural. So I'll stop sharing here so you guys can hopefully see the three of us, and we'll talk through this panel again to kind of set the stage for the rest of the presentations that we're going to be having today, where we're going to kind of talk about innovation in the water space more generally, and a little bit around you know, the specific case study of electrochemical treatment technologies, and kind of hopefully leave today the panel with a bit of a take-home message for everyone about what you guys can do in your day-to-day to help encourage innovation. So Kevin, JC, thank you for joining us and welcome. Great to have you guys on here today. I think maybe we'll just go in sequence here, maybe starting with Kevin. If you guys could introduce yourselves, share a little bit about your role, and talk about kind of your experience, past and current, and you know, plans for the future when it comes to innovation in the water ecosystem. So Kevin, over to you.
Thanks, Steve. Yeah, Kevin Frankowski, Executive Director of Aqua, which stands for Advancing Canadian Water Assets. We're a partnership between the University of Calgary and the City of Calgary. We host research into water, stormwater, wastewater technologies. We also host pilots for technology developers and technology end users, both in the municipal and industrial water and wastewater spaces. You know, my experience with innovation has been varied and you know, very interesting. Started off with working specifically on energy technologies and you know, how to advance innovation there. Coming from a background of civil engineering and entrepreneurship, and realized that innovation isn't some vague arm wavy thing. There is actually a fairly well-defined framework for what innovation is and is not, and there's best practices for how to do it. A lot of those have been developed in other areas of the world, like Silicon Valley, where you know, high tech and things like that need to move at a very quick pace in order to keep up with changing consumer behaviors and consumer demand, and also to provide the requisite return on investment for investors and funders who are supporting that technology development. And so, you know, coming to the energy space and you know, trying to work with both technology developers and technology end users, on innovation, it became apparent that maybe there's things that we as a sector can learn from those who have been doing innovation in a more formalized way. Not to say that the energy sector hasn't been innovative, it always has, but I think sometimes the innovation has been more instinctual and just, we're here in this specific situation. What do we need to do in order to solve this particular problem? I think that there's plenty of opportunity to take a more structured approach to it. And I think that will really help in the conversations that we have around innovation. I think that there's sometimes some confusion around what innovation is. Innovation is not buying new widgets, it's not procurement. Innovation, I would say, if I had to summarize it down to one word, I'd say it's co-development. And I'll leave it there for now. I'm sure that JC and I will have plenty more to dig into in a minute.
Yeah, thanks, Kevin. That's a great way to start things off. So JC, over to you to do a brief intro and talk about your experiences in the oil and gas space.
Sure, thanks, Steve, and good introduction, Kevin, and appreciate you folks having me here and listening to what I have to say. So I'm JC Bourgeois. I'm with Canadian Natural. I'm a water treatment engineer working in the thermal technology development team. And I started my career quite a while ago back in the municipal sector in Eastern Canada, and actually started out doing a lot of pilot testing. So back when membranes were sort of a new thing, and kind of aging myself a little bit here, but membranes weren't really the mainstream in municipal water treatment. So I kind of saw that take a foothold and was I guess part of that. And so the new technologies can obviously become the mainstay, because I think that's the case now in a lot of municipal facilities, as they would go that way. But yeah, then I am now working at Canadian Natural. Went to Shell for a few years, ended up at Canadian Natural after we got bought out. And so mostly working on, like I said, thermal in situ type water treatment processes. I also do some operational support, and I'm also the chair of the WTDC, which is the Water Technology Development Center, which is the Suncor Firebag piloting facility that was constructed. The technical committee chair for that facility. So so I've seen I guess some technology development on both sides. I guess going forward too, I'll probably continue to do that and continue to provide operational support and so on. So I guess in the innovation space, I mean, I've been, I guess, involved in water treatment and new technologies pretty much my entire career, as you can imagine. We're always looking for new and better ways to do things, and it's been a bit of a challenge. And what I'd like to to do is it's been hard for facilities like ours to adopt new technologies. I mean, I think some real interesting ones, or big ones, I guess I would say, are things like just using SAGD to unlock. I mean, we used to mine our resources, and then we moved to SAGD, which is seam assisted gravity drainage, to I guess develop our resources, and then we moved on to evaporators. Let me back up here. So that was a big innovation in and of itself, and then we went within that, the warm lime softening and hot lime softening processes were the main water treatment process that we utilized. We moved on to evaporators. So we've seen a few changes in the water treatment space within the in situ world, and we probably need a few more. They're very large and costly processes. It took a long time to develop those processes and get comfortable with them. And I think that's one of the main challenges with our operating companies, that we struggle to gain the confidence to adopt new processes, simply because we have a commodity product on the line and production is at risk. So we need to do a lot of testing, piloting, to get comfortable with that, and then move on with a new process. And I guess we're here to talk today a little bit about electrocoagulation, electrochemical oxidation type processes. And, they've been around for a long time. EC is a process that's been probably in existence for nearly 100 years. And, I think, people haven't really maybe completely understood how it works. It's been a little bit hit or miss over the years. But we're making strides and trying to learn how to better utilize that technology within an oil and gas environment. So there's a lot of great research going on, and that'll be talked about a little bit here going forward. But I guess just coming back to, some other barriers to just technology in general, and specifically within water treatment to get adoption in the oil and gas industry. So these things take a long time and to develop, and we need to find, I guess, ways to do that a little bit quicker. Obviously, there's patenting involved, which can extend timelines as well. And when I mentioned about, the reluctance to take on technology, new technology risks, one of the reasons that we developed the WTDC was exactly to do that. Another challenge that we've had is finding the ability to test on live fluids. That's always been a challenge. So the WTDC was another example of how we've tried to improve that. Sharing technology and the results and learnings, that's been a challenge as well. And I think OSEA has actually been pretty instrumental in, I guess, connecting the dots and bringing people together and allowing us to innovate and collaborate and share. So there's been a number of challenges over the years, but we've also found ways to largely overcome those, but we still have a number of them. I have a whole list of them here in front of me that I wrote down. I won't get into them all because I don't have time, but I'll leave it at that for now, and then I guess see where the rest of the conversation takes us. So thanks.
Yeah, thanks, JC. You touched on quite a few kind of interesting challenges and concepts that, each of those could take their own webinar to unpack and explore. So we can't, like you said, can't get into the detail too much, but that's a great overview of some of the challenges that you see around, bringing in new technologies in the oil and gas space for water. And I want to pass it back to Kevin, and then we can jump back to you, JC. But in thinking about some of the challenges that you've encountered or that JC has laid out, I want to switch a little bit to overcoming those barriers. If there are barriers to innovation that you've encountered, can you give some specific examples of how those have been overcome and kind of the lessons learned along the way?
That's an important question, Steve. I think the critical thing in overcoming innovation challenges is to learn fast. Sometimes that's characterized as fail fast. In safety conscious industrial environments, that's not necessarily the right way to phrase it. But I think learn fast and learn by doing specifically. I think there's sometimes, us technical folks in the room, especially us engineers, analysis paralysis, and let's figure it out on paper before we move forward with something in reality. And I think that's limiting. That's slow, but it also doesn't give us the full information. So I'll just give two examples from the aqua world. Last year, we launched a reuse beer. So it was Alberta's first potable reuse project. And it started off as kind of a conceptual conversation about, hey, what if we could take wastewater, municipal wastewater, and brew beer with it? And, it was kind of chuckles around the table about, that sounds kind of crazy. And then one of our team members, Christine, she said, well, let's just try it, right? And so we did, and we worked with Alberta Health Services very closely, along with Village Brewery and Xylem, the technology provider, and just figured out each step along the way. And it was only by just sort of stepping in and trying things in this iterative, sandbox fashion that we were able to figure out how to solve specific things. If we would have tried to solve this on paper and then implemented it, literally would never have gotten off the ground. But once there's a certain momentum going, you just need to keep it going. The other example I'll give is our COVID and wastewater monitoring project. So now, in partnership with the University of Alberta, U of C and U of A and Aqua have this Pan Alberta monitoring program for COVID and wastewater, and it's become a pretty important feature in Alberta's landscape of COVID response. And, people go to the COVID tracker on a daily basis just to watch what the numbers are doing across a number of communities across Alberta. But when we first started this project, like the team that we pulled together is very multidisciplinary, and there wasn't a single person on the team that had all the answers. And so if we would have tried to do this on paper first and say, well, okay, so we need to find that expert that knows everything. We just, that person doesn't exist. It still doesn't exist even 2 years after building all this experience. And so we started at the end that we knew, and we gradually just grew the program. And if someone would have said to me 2 years from now, the premier is going to be quoting your wastewater numbers on a monthly basis or weekly basis, I wouldn't have believed them. But that's where we are today. And we've made great strides in figuring out all sorts of challenges. And trust me, there's been tons of challenges, but until you kind of roll up your sleeves and just start. And it really was, going back to my earlier comment about co-development, it really was a co-development approach. It wasn't about Alberta Health Services or anyone else procuring this from us. It was like, okay, well, what's the challenge? What are the questions that need to be answered, and how are we going to do that? And we just literally started doing these small pilots. Does it work on the bench? Does it work at one site in the field? And are we perfect? No, but are we much further ahead than where we would have been? Absolutely.
Yeah, thanks, Kevin. Those are some really great examples, and that link you make to that co-development idea is such an important one. So JC, I want to pass it to you just for one kind of, looking at the time, if you can give one specific example of overcoming those barriers in your experience, and maybe that in that co-development frame, and then we'll move to the take-home messages for both of you. But JC, over to you.
Yeah, yeah, thanks. Yeah, building upon that, I mean, I mentioned it earlier, and I have to kind of highlight it because it is the shining example that we've had at the moment within our industry, and that is, of course, the WTC. It's a we used to do these projects individually. We'd engage a vendor, get them to articulate an opportunity within our facilities. We'd maybe, go test it, maybe not, depending on the cost, but we're all doing this separately and individually, and it was costing a lot of money. And you can't do that for every technology. So, we kind of woke up and realized that, hey, maybe we can collaborate on these things. And obviously, our social license to operate, a number of years ago was being challenged. And so we needed to find a way to accelerate that technology development. And I mentioned it earlier in the long timelines, and that's a real challenge, because often by the time you need the technology, or when you need the technology, you're just kind of starting that development. And by the time your project that could have used it is finished, it's too late. So we often miss the boat in that sense. So what we wanted to do was have a large facility, and what the WTC is basically a big garage for testing water treatment technologies. And so having a facility like that, where we can bring technologies in and rapidly test them, and it's a multi-company partnership. It started out with 6 companies, and now it's 4. That's through acquisitions, but still, yeah. So we're sharing brain power, we're sharing financial resources, we're sharing space, and we're all collaborating, both with individual companies and with vendors. And there's still a little bit of a piece missing, and I think that's where maybe Aqua and locate facilities like that or organizations like that can kind of help, and that is bridging the gap between the research piece and when we get to a piloting phase. There's still a bit of a gap there, and we still struggle a little bit to make that linkage. But yeah, once we have something that's endorsed by operating companies, we can get it to the WTC, we can test it in rapid fashion. And the intent coming out of that facility is that now we're in a position to go commercial with something. So we've tested on live fluids at temperature and pressure, without aging of samples, at larger volumes, versus totes and things like that. So yeah, that's been I would say our success story to try to address a number of those challenges.
Yeah, thanks, JC. That's a really cool example of, like you said, collaboration within the companies, but also then you're doing that co-development with the vendors and technology providers along the way to get them to that point. where they can do the piloting. So hard to believe, but our 20-minute discussion has zipped by just like that. So I want to give each of you guys a chance to have a closing thought in kind of a minute or so of, in reflecting on the challenges and some of the opportunities and examples of overcoming those barriers to innovation. What would you want to leave with our audience as kind of the take home call to action to move forward in this? So JC, maybe I'll start with you in a minute, and then I'll pass to Kevin for his closing thoughts.
A call to action. Okay. Yeah, we just need to find a way to. I would say that the point I made earlier, which is making the linkage from the university research. A vendor's got a great idea, but doesn't really know where it fits. And I think that's, often we find trying to fit the square peg into the round hole doesn't really work. Like we need to identify, find a way to quickly identify where a particular technology might or might not have an opportunity. We can't evaluate them all. We can't evaluate every technology for every potential application within our facilities. There's just not enough manpower time to do that. So we got to come up with a way to figure out, does it work on a few key water compositions that we might have? And we're not necessarily going to get this up to site and built to an industrial spec and test it right away. So how are we going to do that? How are we going to get something that's sort of at a laboratory scale, hasn't even really thought about being constructed in a in an industrial fashion? Can we do something with plastic and so on in a low temperature application? And where are we going to do that? And then how are we going to prove to an operating company that there's meat on the bones here, there's something that could potentially go forward? And where are we going to do it? And how are we going to get to that, that ideation to the, I guess, where there's enough material or enough of an opportunity, enough of potential economic benefit that we're going to get energized about it and amped up about it, and then work with that company and our partners as well, not just in the WTDC, but maybe other CHIPS, joint industry projects is what I'm referring to, that we might collaborate on and get it to a pilot phase where then we would then go and prove it out. So it's really, there's so many ideas in the funnel, and we just need to figure out how to make that happen a little bit quicker.
Thanks, JC. And Kevin, your thoughts on call to action?
Yeah, two closing comments. Thanks, Steve. Two closing comments. Innovation is hard. You can't do it alone. And so reach out to the ecosystem. Adele mentioned earlier about CRIN and the website, the LinkedIn group, the newsletter. So that's an excellent on-ramp for the innovation ecosystem. Come take a tour of Aqua. Go to our website, ucalgary.ca/Aqua ACWA, and just click on one of the three of us, myself, Christine, or Dr. Lee Jackson. Reach out to us. Our email addresses are there. We'll give you a tour. We'll talk about ways that we can help you as you move through the innovation process. The second thing is, just to steal a slogan from Nike, just do it, right? Like the key thing here is to learn by doing. And so, you don't need to do one pilot. You don't need to do the single, swing for the fences kind of thing. You can start with small pilots. And, JC was just mentioning, do you need to start with an industrial scale, steel and all that, or can you start with smaller things? And so take this iterative approach. You'll learn things along the way, and let's just find those small initial on-ramps to piloting where we can do it, because we're going to learn way more doing that than we will staring at spreadsheets.
Okay, that's a nice way to end it. Just do it. We'll figure out the trademarking after. So thanks, Kevin and JC. Thank you guys very much for your time and your thoughts here. And for those in our audience, if we have time at the end, we may be able to bring JC and Kevin back for some questions. But right now, we're going to move on to our speakers. So as I mentioned off the top, we kind of had Kevin and JC to set the stage and set the context. And now we're going to have individual presenters, technology developers, researchers who can share their own experiences working through the innovation ecosystem. So we have Dr. Ted Roberts from the University of Calgary. He has, unfortunately, is a conflict right now with Minister Schweitzer is knocking at his door, so he won't be able to present live, but he will, he sent us a video, so we'll play that right now, and he'll join us towards the end of the session. So if you have questions for him, you can put them in the chat now, and I'll make a note of them, and we'll see if we can get those answered later on. But for now, I think he does a good job to kind of set the stage for the rest of the presentation. So we'll listen to this video, and then we'll dig into the rest. So I will play Dr. Roberts now.
Good morning. First of all, I'd like to thank the CRIN team for giving me this opportunity to present some of our work on electrochemical water treatment. And what I would like to do through this presentation is cover three topics. First of all, I'll give my views and some introduction to electrochemical water treatment technologies, the range of technologies and what they can be used for. And then I'll talk about a little bit about my experience with the innovation process, and the things that can go wrong and how to perhaps do it better. And finally, I will discuss as a brief example our work on electrocoagulation for produced water treatment in the oil sands industry. So first of all, just some general overview of electrochemical water treatment technology. So I just put at the top some of the characteristics, pros and cons of the technologies in general. And so in electrochemistry, we're using electrical current to do oxidation reduction reactions. And so because we're using electrons directly, we can do those processes without having to add chemicals to the water. We have a second characteristic is the tunability of the process. So we can change the applied potential or the applied current during the treatment to tune the process for the stream that's being treated. And that tunability applies both in the design and in operation. It can be also related to that a very responsive process, so we can turn up or turn down the treatment intensity. And it typically has a relatively low footprint. Some challenges with electrochemical water treatment is you generally require conductive solutions. In some technologies, you also require clean solutions. You can generate a very corrosive environment because you can generate oxidizing species. And so some of the materials requirements can lead to high capital costs in some cases. In addition, but because of that corrosive environment, because of that electrical energy you're applying, you often can't use just steel tanks because you'll get corrosion currents in the steel. So that corrosive environments leads to some costly material, especially for the anodes in electrochemical cells. And then, of course, there's the electrical energy cost. So you're using potentially a high cost energy to drive the process. Sorts of technologies that are available for water treatment. I've got a couple of pictures of processes that I've worked on and developed in the past. So you can use electrodeposition to recover metals from wastewater. Generally, it's good for relatively pure solutions. So things like rinse water from electroplating lines. And that uses a graphite felt where we deposit the metal. Then we have electrooxidation, where we can oxidize organics, used for dilute concentrations of problem recalcitrant organics. Electrodialysis, where we use an ion selective membranes to separate out salts. We can use it for desalination, and we can use it for salt splitting, so converting sodium sulfate into sodium hydroxide and sulfuric acid, for example. Then there's capacitive deionization, which is an emerging technology for desalination, where we absorb ions onto the electrode and then release them into a concentrate solution. And finally, electrocoagulation, which I'm going to talk about in more detail in this presentation. So I said I'd talk about the innovation process. So I've seen successes and failures over my career in many different ways. And you know, when I came to Calgary, I was interested in looking at electrocoagulation for produced water treatment. And I talked to several people in the industry, and they told me, oh, we tried it and it didn't work. And that idea of, oh, we tried it and it didn't work, I've heard many, many times, for not only for these technologies, but many others, especially in the environmental space. So the kind of what happens happens is an end user says, oh, they come across this technology and they think, oh, that sounds like it's a good fit. The vendor tells them that all the benefits of this great technology, and they try it and it doesn't work. And that's the end of the story. So they invest a lot of money in doing pilot tests, and it fails quite quickly. But so that's kind of happens 9 times out of 10 when you do that approach, I would say, and because of the investment, and that's regarded as lost investment, it's kind of a killer for the technology. No one goes back and tries it again. So the other strategy that fails often comes from the academic side, where I work. And so, we research and try to understand the technology, what its pros and cons are, what the mechanism is, and then we come up with some novel concepts trying to innovate the technology, and we come up with a solution. But if we don't really understand the application, we often end up with a solution that's looking for a problem. And there are many examples of that, especially in the academic space. And so what you really need to do is work together. So I think I've shown it as 2 boxes, but essentially I think it's 3. It's universities, the technology provider, and the end user need to work together. So we understand all of these issues together. And it is not about plugging a solution into the application. It is about understanding what's going on, iterating that until you have a tailored solution that's well suited to the application. So for me, that's an iterative process, and not just try it and see. So for our case study of electrocoagulation for oil sands produced water, so what is electrocoagulation? Very simple in concept, at least superficially simple. We simply put 2 metals, usually aluminum or iron electrodes, into the water. We pass a DC current that we suck electrons out of the anode, and that dissolves the metal into the water. At the cathode, we electrolyze the water, produce hydroxide ions, and that ends up as a metal hydroxide coagulant. So essentially, we're using electricity to dose the solution with a metal hydroxide, which coagulates and removes contaminants. One of the challenges we've been looking at is the formation of passivating or fouling layers on the electrodes, which is one of the major challenges for this technology. And so I'm not going to go through all the detail of what we've been doing, but we've been studying, trying to understand what's happening in this process, and it's extremely complicated. And so for the application, we have a salty produced water that has some other ions in it, and we have a target contaminants, particularly silicate, calcium, and magnesium. One of the things we've been studying is trying to understand what's happening at the electrodes, and these videos are showing you the pH distribution close to the electrode, and you generate this acid solution on the anode, but you also generate this alkaline solution at the cathode, and that can lead to precipitation on both electrodes of fouling layers and causes problems for our operation. And what we've also been looking at, we've used many different techniques. So we can visualize the fouling layer. We can observe things like gas bubbles inside the precipitate. And we can also see that when we do electrochemical experiments, that the ions can affect the height of this line on the right-hand side here tells us how much the rate of corrosion, the rate of dosing of the metal ion at different potentials. And what you find is with salt, salt is, it helps the metal dissolve with sodium chloride, but with sulfate, it actually passivates and stops that process. And in our produced water, we have both sodium chloride and sodium sulfate. And so the sodium chloride helps our solutions dissolve. And so we can, through our experiments, try and understand what the role of all of these components in our application have on the process. And that enables us to do innovation and design and tailor the process for the application. So what we've been able to do is reduce the energy consumption and enhance the contaminant removal through that process. And that requires us to tailor the cell design, the electrode materials, and the operating conditions to achieve that. So just to wrap up, so I really think that for these kind of especially for water treatment applications, you need this cooperative approach to make a tailored solution, and not to just give it a go and fail and give up. I would, of course, add that it is not only a technical story, there is also the economics, the commercialization pathway. IP is often a challenge. Who owns it and how is it going to be exploited? The cost of the investment required to scale up and the people involved. We've also often failed because our the person in the company that's helping us leaves, and then we're left. No one's interested anymore. That can also be a problem. So just to wrap up, I'd like to thank the sponsors of our research and our industry partners, and of course all of our researchers. I should tell you that we've had about 15 person years of research being on electrocoagulation for the produced water application. Okay, thank you very much. I'll be happy to answer any questions after the presentation.
Okay, so yeah, thank you to Dr. Roberts. And again, he will be joining us later, hopefully after his meeting with Minister Schweitzer, to answer any questions. So if you have any, please do put those in the chat and we'll get to those towards the end of the presentations. So next up, I'd like to welcome Sean Frisky from Ground Effects. He's the president and CEO there to take us through his experience in the innovation ecosystem. So Sean, over to you.
Sure. I'd like to apologize up front if my voice fails me. I've recently contracted COVID. So anyway, we'll start off here. So give you a little history on Ground Effects. We've been around this is our 24th year in business. And we have a culture of innovation. And one of the things we've developed is our EOX process for oil and gas and other water treatment wastewaters. So how do we do this slide? Is that you? There we go.
Yeah, just let me know when you want to switch to the next one.
Sure. Sure. So the next slide, I'll get into kind of the history and the costs and kind of the journey that we've been on with this technology. But these are some of the different contaminants of concern that we've proven it out, not only in the lab, but in the field. Won't really get into these now, but a lot of these are, refinery / SAGD / frack water problems. And what we like about electrocatalytic oxidation is it has that broad spectrum and can do a lot of different things, as Ted alluded to in his presentation. I think you can go to the next slide. Just gonna need some water to keep the voice going. So this slide really was to represent the journey, right? So we started this on the water side around 2006, just starting off doing lab testing. So obviously there's, an investment to build lab equipment and to do that, but it was quite small at that point. And then the next phase was, okay, we're gonna take this to the field. We've proven that there's something there, and we think, it could be viable. And now we have to build a system that can be taken to the field and demonstrated to a customer. And so we always take the approach, kind of along JC's line, is we don't typically just build something and hope somebody will come. We try to engage a customer, and even if that's some sort of rental contract or something, so we have customer engagement, and it is essentially a joint development, customer paid R&D, if you will, where we're not going to profit from it, but it's not going to cost us a tremendous amount of cash between grants that are potentially available and customer. It's like we try to come out of it relatively whole, but there's still an investment in that technology. So pardon me. So if you look in the early days, the cost to develop the first process was around, 450 grand. As you scale up the technology and for different applications, that investment becomes larger and larger and larger. So this slide is really just to show industry what it actually takes, right? It takes this isn't software technology that you turn into $1 billion opportunity overnight. This is something where it takes time, it takes money, and you got to be in it for the long haul. And so you can see 2017, we're doing 5,200 cubes a day in a municipal application. So also we're looking at different applications where it could be viable. 2018 deployed our first SAGD produced water, 2,500 cubes a day. And you can see at that point we're generation 3. So we've basically completely changed the technology and the process by that point. And there's a significant investment up until that point. Now, some of the larger scale SAGD opportunities are, in the order of 60,000 cubes a day. And so we've done an initial design for that as well. Now, we haven't commercialized that, and that is, you're looking at more of a $30 to $50 million. So you can really see how, as the technology ramps up in scale, the investment into that technology becomes greater and greater, which we need to de-risk this for the customer, right? So we need to continue to make these investments and continue to develop this so that, and partially together so that it gets the traction it needs in industry. Next slide, please. So I'll just talk very high level about the technology. So the picture on the left, that's our SAGD EOX reactor. It's insulated for thermal properties, things like that. So that's a single reactor that does 2,500 cubes a day for removing silica, oils, suspended solids, hardness, those kinds of things. Lower right-hand corners are 5,200 cube a day. So these are pressurized units. So they can do high pressure, high temperature. That's 5,200 cubes a day. So just for reference, how big that actually is, each of those reactors is a 6-foot diameter reactor. So it's quite small footprint. And then the upper right-hand corner is our pocket EOX. So this is something we've developed and basically just given away to countries that don't have clean drinking water. So this is a very tiny unit that we've had families of 10 in Africa that will support their drinking water supply, and it's run off of solar. So these are some of the kind of neat things you can do with electricity and treating water, right? So yeah, that's it on that one. Next slide, please. The other point I wanted to make is that the electrochemical technology isn't standalone for the most part. As far as oxidation, I guess it can be, but in typical oil and gas, there's the emulsions, the oils, the suspended solids, all those things. So we look at it as it's the reactor. It's the thing that makes things happen. And then we need a process. So it's not only developing that single technology, but then the entire process to go with it. Like most wastewater treatment processes, there's not too many that are single step, right? So we use our EOX reactor combined with the fused nitrogen flotation. And that's really what, basically separates out all of your solids, your coagulated, materials, right? So everything that becomes a solid then can be separated off as a sludge. Next slide, please. I'll just mention quickly before I get into this slide. So then we would typically follow that with some type of filtration, and it would depend on what the customer requirements are. So it could be from a simple media filtration or it could be submerged ceramic membrane. So somewhere, depending on what the requirements are. Our EDOS system. So one of the cool things about this technology, because its ability to be tunable, is the electrode gap, the electrode size, the reactor size. Those are all sort of physical things that we would test in the lab before actually building a system for a site. When we're on site, the easily tunable things are electrode gap and amperage. So most of the tuning is based on amperage. And so we can actually put in instrumentation on the back end. So if we aren't meeting one of our desired criteria for effluent, the system can automatically essentially dose, as Ted alluded to in his presentation. It can dose more electrode and create more electrochemical reactions simply by turning up the amperage. So it's a very tunable in the field type system that can be completely automated to maximize efficiencies, both from a electrical consumption and effluent criteria perspective. Next slide, please. So this is just to give you a flavor of what a modular plant looks like in say SAGD. So we have our EOX building. I did this with paint. I don't know if you can tell that, but so the EOX building is on the right, and then the one in green is the pump house building, which houses all of the pumps. And then the filtration building is in the back, and the DNF's the orange in the left. So that's a complete process, sort of EOX, DNF, then filter. And it was all built modular. So it was built at our facility and then shipped out. So on-site time, very quick. And I think this is important because if you compare it to hot and warm lime softening, for instance, for SAGD, it can be built offsite, which always reduces costs. It can be scaled up or down. So it could be 500 cubes a day and used for one set of wells, SAGD wells, or it could be, 50,000 cubes a day and at a centralized facility. So, and what we've learned from this is that our CapEx is, a fraction, like in the order of 30 to 50% of what a normal plant would cost. And our OpEx is, in the 50 to 70%. So this technology, I think, has a great future because of those two things. And the third thing being that it's modular and small footprint. Next slide, please.
And Sean, just a time check here. You've got another minute or two.
Okay. Yeah, I think we're just about wrapping up. So the applications for oil and gas are SAGD, frac flowback ponds, water flood, and refinery wastewater. The benefits are low OpEx, small footprint, reduces greenhouse gases. In the case of SAGD, you could reduce your natural gas consumption as well by treating it warm, hot, water quality for reuse, modular construction. The greenhouse gases and natural gas contribute to the ESG improvement. And in the case of we're doing some refinery work where it's regulatory compliance is the thing we're trying to achieve. Last slide. Second last slide. So how we do this for a customer typically is we would do a lab pilot, rental, something like that. Then that allows us to model, size it, both CapEx and OpEx. And we can do complete layout design, integration services, field tech support, and turnkey water treatment. Next slide, please. Yeah, hit it one more time there. So the point of this slide, this is kind of the ask, I guess, is one of the things we're considering looking at is typically we've done capital equipment sales and provided the tech support, consumables, all those good things. We believe there's a market in doing a turnkey service, and we're doing this for some refineries right now where we come in, provide the equipment, the OpEx, the people, and we charge dollars per cubic meter. So the advantage to the customer is there's no technology risk, there's no CapEx risk. It becomes off balance sheet financing, almost like a lease for them. And there's a known cost per cube. And this allows the producers to focus on oil production, not water treatment. Some of these, in SAGD, essentially they produce 3 times as much water as they do oil. So they are water treatment plants that produce oil as a byproduct, essentially. And we believe there's a model there that we can de-risk and use this technology. And so the ask is for feedback on this model. Is this something they think would be of interest, or they just, customers like capital equipment sales as well. So we believe this is the future of water, is providing that service. I'm going to end there because I can't talk anymore. Thank you.
Great. Well, thanks, Sean, for battling through that. I hope you have a speedy recovery. I like the way you laid out in one of your first slides, that kind of life that you've had to go through, all the different steps and costs that build up over time. I don't see any questions in the chat. There's a question about kind of contact information. We will make that available. So feel free to reach out to our speakers afterwards and answering that question that Sean posed to everyone about the interest in that service. Okay, I see a couple coming in here. We're a little over time on this. So Sean, if you don't mind looking at those in chat and maybe responding to a couple of those, we will move on now to our next speaker. Pleased to welcome Norman Keeble. He's the president of Boydell Wastewater Technologies. So Norman, over to you.
Okay, thanks a lot, Steve. Good morning. I'm Norman Keeble. I'm president of Boydell Wastewater Technologies. And we don't really have a lot of time here, so I'm just going to give you a very quick introduction to the company, describe a little bit about our innovation journey, and then finish up with some lessons learned. And I think we'll find that it's a pretty common theme with the rest of the group who've been talking about a lot of these lessons. But anyways, if you go to the next slide. Thank you. So Boydell is a Vancouver Island-based company that makes an electrochemical water treatment process called the water miner. And it essentially combines both electrocoagulation and electrooxidation within the same reactor cell. And that's really the core to our technology. And the two reactions, or the two processes, typically enhance each other. And being so close together, we find we get incredibly good performance from both. So you end up with something that kind of that combined is better than the sum of the parts, so to speak. The company was started over 10 years ago, and basically our two founders, who lived in Ladysmith, discovered that their local wastewater treatment plant was going to be upgraded, and the cost was so high they decided there had to be a better way. And one of them, Randy Boyle, who's on the left in this picture, he had worked a lot with boats and had dabbled in electrochemical water treatment there. And he figured he could scale that up into something bigger. And they started on the journey of developing a water miner. It was a long journey, but we did end up with what was a absolutely fantastic way to treat sewage. But unfortunately, we also found out that municipalities are very difficult and long sales processes. Municipal engineers have very little incentive to try something new, and understandably, they're very risk averse. So they want to see something that's got many, many years of proven operation behind it. And that wasn't our company. So like many new developers and many innovators, we decided to pivot at that point. And we started looking for applications where there was a lot more incentive to try something new. Industrial operators who might have high growing pressures, social pressures or cost pressures on their water treatment. and where we saw our technology having the biggest advantages. So that leads us to wastewaters, or very high strength wastewaters that have very high levels of solids, COD, heavy metals, fats, oils, and grease, and other contaminants. And this is pretty common in food and animal processing industries. It's common in oil and gas applications. It's common in Belgian ballast water applications. And so that's where we're focusing most of our efforts now. We do find we've got some pretty interesting applications elsewhere, but part of the innovation process is trying to focus on where you have the highest impact, and that's what we believe we do. Next slide, please. So a little bit about our innovation journey. I'm not going to go into huge details about the technology itself because we don't have time, but essentially innovation takes a long time. We are no exception to this rule. Really, we started with a very simple cobbled together proof of concept in 2009, and it's gone through numerous iterations over the year. Lots of refinements, lots of testing, refining, rebuilding, redesigning, retesting, and iterative over that process. But eventually we got something that works very effectively and reliably. We spent countless hours, over thousands of hours testing this system at lab scale, testing different combinations of electrode materials. Because we use electrooxidation, we were testing different MMOs, our mixed metal oxide coatings, testing how the current intensities affect our systems, and testing all the different parameters, chemical parameters. And as you can imagine, every water is different. So because we were trying all sorts of different things from sewage to oil and gas, you end up with an awful long time of trying to narrow in on the exact parameters that work. This picture just shows a little bit of the progression from the early stage prototype through the years, and the two on the right are our first commercial systems. 1 second from the right is a 1,000 cubic meter per day reactor, and then the far right one is one that is being commissioned in an AUS mine site application as we speak. We've also run a number of large pilots. We ran an 18-month pilot at a US septic receiving facility, which actually worked very well, but unfortunately they were never able to secure enough supply to turn that into a permanent installation, so it ended up dying on the vine. All this is just to say, it takes a long time to innovate. It takes a long time to go from that concept to something that works well and the customers want, and that I don't think we're ever going to stop innovating. Next slide, please. So just in terms of the innovation process now, so now we're looking at different waters, but every water is different. So when a customer comes to us with a potential application, we really start out with a simple paper exercise to decide whether it makes any sense at all. If it's all dissolved solids, we wouldn't touch it. But if we decide we want to go with it and we think we can do something, then we'll immediately start with small samples that we'll take into the bench, do just very simple lab testing and determine whether we can get the separation of solids and water and whether we can get the performance we want. If we decide that from there that it's worth testing further, we make a much larger sample, 1,000 liters or so, and then we bring it in and we run it through a continuous sort of 3 liter per minute lab scale system, where we can really refine the parameters, understand the water well, and get to exactly where we need to be. We also take it one step further and take a mobile lab set to our customer's facility, which sometimes gives you a lot better real world application because you're testing the water right out of the process and not chasing something that might be 6 months old or 2 weeks old at least. Finally, if all goes well to that point, you go to the next stage, and if we're lucky, then a customer might be willing to go straight to a full project. But really, because we don't have all that many systems out there, we're a young company, typically they're going to want to see a pilot, and that's where things sort of take a step in the negative, and in that it becomes very expensive to do a pilot at a meaningful scale with this kind of equipment. And so our customer has the option of helping to fund a what could be a risky, high-cost pilot, or stepping aside and just walking away. And unfortunately, I know a lot of technologies end up in the same boat as this. I've been in technology development all my life, and it really is a point where good ideas can die. So next slide, please. Just quickly, some really simple lessons learned. One of the first things that I would say we learned is that demonstrations really do matter. As I said, if people need to see it working, to find a very early adopter for a new $500 consumer gadget may be easy. Trying to get somebody to commit to $1 million water treatment plant that they've never seen is much more difficult. So getting demonstrations out there is important. And we haven't been particularly good at this. I mentioned the 18-month pilot that was done many, many years ago when we were working with another engineering firm. And since then, we haven't really had the ability to put these things in the field and get people out there. We're trying to change that, but it's a challenging process. And part of the reason we were able to do the 18-month pilot is because we had the wherewithal or the cash flow of the large engineering firm who was partnering with us to do it. And I don't think we could have done it for as long or as successfully without that. Next slide. Next, capitalization matters, and this flows into the above statement. I mean, you need to have the cash to develop these technologies. It's fairly easy at the lab scale. As soon as you start to ramp up, you do need capital. I think that this is an opportunity for industry and the smaller startups or early startups to work together to find creative ways to fund these things. And we are actually working on that on financing, but it is challenging to finance new technologies, and it really can stifle innovation pretty quickly. Last slide, please. So the last one, and this has been the theme throughout, collaboration really matters, and we're finding this. Everybody does better when we work together, when industry works with, end users work with innovators, when you bring in the universities, when you bring in industry groups. The challenge is it doesn't always work in real life. There can be some real mismatches between larger industry players and smaller startups. I've seen this on IP, who owns the IP. It's the lifeblood of a small company, but the larger players may feel that they're helping to fund this thing, so they need to own part of it. There can be timing mismatches. We've had projects that were critical to us and high urgency, and we're really just not that urgent to the larger player that we're working with. So I think we need to find really creative ways to work together, particularly, this is from our experience, is these smaller companies just starting out need to be able to work with the large companies. There need to be creative ways to finance these projects and creative ways to, maybe it's as simple as bringing in resources and people from the large company to help support the pilots. I don't know, there's a ton of different ideas that can be out there. I'm just sort of throwing some out, but I think that creative collaboration is something that we've missed, and I think can make a huge difference. I'm going to stop there because I think I've made my 10 minutes, but I'd be happy to answer any questions.
Hey, thanks, Norman. That's an awesome presentation, and I like some of the links there to that idea that Kevin talked about in JC about co-creation, co-development, and innovation is hard. Don't see any questions in the chat at this point, but if any pop up, maybe you can respond directly like Sean has, and we'll move on to our last speaker and just make sure we get done on time. So thanks again, Norman, for your thoughts here, and let's move on to our fourth presentation from Axine Water Technologies. I'm pleased to welcome Krista Ramirez, who is the Director of Sales for the Americas, to present. So Krista, over to you.
Thank you, Steve. Yeah, I'm Krista Ramirez. I am the Director of Sales at Axine. Thank you guys for inviting us and for putting on such a good event. You can go next slide. So I am located, I'm not a Canadian, I am located in Minneapolis, Minnesota. I just joined Axine back in October, so be gentle on me with your questions because I might not know the answer. But we are a Vancouver-based company. We've got a nice facility on the UBC campus. Mostly it's lab space there. And we were founded in 2010, so we're a pretty young company. And what we do, we've got a wastewater as a service business model. So a little bit like, I think it was Sean was describing, like, maybe this is what we should do. It sounded a little bit familiar. And I'll go a little more into that as I get into my other slides. But what we offer for our customers is on-site destruction of the toughest organics in industrial wastewater. So things like active pharmaceutical ingredients, solvents, pesticides, PFAS, and we combine an advanced electrochemical oxidation technology with our modular system design, some data analytics and machine learning. We've got over 35 patents to date, and I imagine we'll continue to get a lot more. On the right there, you can see we're venture capital backed, and we've also taken advantage of a lot of the fantastic programs that the Canadian government has to support, the clean tech industry. So we're very fortunate with that. Next slide. So just to help wrap your head around what wastewater as a treatment, what that service model looks like, it looks something like this. So the customer, when we're working with the customer, so they'll give us what their incoming wastewater specification is, what that expected water quality is going to be. We'll likely need to do treatability testing and or a pilot. So similar to what the other gentleman before me were describing, that customer will pay us an annual service fee. We work on multi-year service agreements. So our standard is 5 years and it renews after that annually. They will provide any of the infrastructure, so the electrical, the plumbing that needs to go to our system, and they'll pay for that electrical. And then they'll do probably a little bit of routine operations. So maybe like some of the chemical handling, those consumables, maybe filter changes, depends on the size of the system and how present we are. And then they'll take care of permitting. And what Axine does is we'll design, we build, we install, we operate, we monitor 24/7. We take care of the service and maintenance on site with that treatment system. So it really is a service. So a lot of these customers typically don't even have any kind of treatment, or they just have like light pre-treatment. And what they might be doing is having their wastewater, their contaminated wastewater trucked off site for incineration or deep well injection. So in our case, at least with the customers that we're working with, it's not that big of a shift for them to go from one service to the other. It obviously looks and feels like capital equipment because we're installing it on site. But it's not, because Axine owns the equipment, right? And so with that, and we operate it. And so with that, we'll treat the wastewater to the agreed upon specification where they can then discharge as they please. If you can advance one more. And this benefits the customer. Obviously, one, we're giving them a performance guarantee. Again, this sounds familiar with what some of my colleagues here have said, but low project and technology risk. You know, it's including all of the service and maintenance. It's a minimum capital investment, and it's very cost effective, both for us and for the customers. Next slide, please. And you can advance it one more. So our electrodes are packaged. Obviously, everyone here is talking about electrochemical oxidation, but just to give some context, in Axine's approach is they're packaged in proprietary reactors, which you can see in the center there, that up close photo. Reactors are then integrated with power supply, controls, automation software into these standard modular units. And we treat the wastewater on a batch basis. The data is used then to verify the treatment, tracking power consumption, predictive maintenance, and it's providing real-time feedback to the plant as well as to Axine. And we leverage machine learning and enhanced data analytics to improve that efficiency. We don't do continuous improvement, rather we're trying to improve with leaps and bounds. But because this is a service model, just like if you've got an iPhone, There's a software update that's going to hopefully not be a glitch. It's going to be a real improvement to you at no cost. That's the same premise that we do with our customers. As we make improvements, our customers, as long as they've got a service agreement with us, they're getting those same benefits and those improvements. Next slide, please. And here's just an example of some of the stuff that you'd see in our system. So on the upper left-hand corner, you'll see 2 40-foot and 1 20-foot container. That is one complete system that was recently installed in Barceloneta, Puerto Rico. If you go on our LinkedIn feed, you can see a little video about that system and pharmaceutical plant there. So inside, these are some of the unit processes you'd see inside. So we do pH adjustment, RO, obviously our electrochemical reactors, among other things. And so everything you see there, as you can see, it's skid mounted. So we can either skid mount these things and have the customers install, in their own infrastructure, or we can deploy in a containerized manner like you see there. Next slide, please. So challenges. So as I mentioned, I am very new with Axine, so I'm going to do the best I can with this. I'm sure there are more challenges. But first and foremost, the WaS business model. It's absolutely challenging. To date, so we were founded in 2010. Our first commercial install, I believe, happened in 2018. So only, 4 years ago. And now we've got 4 systems installed, and we've got what looks like a healthy pipeline. But the fact of the matter is this is a disruptive business model. It's not what people are used to doing. They're used to buying capital equipment, right? But with that, I think that there's a lot of advantages that come with this service model. So, we're dealing mostly with, or exclusively with rather, industrial facilities. And so industrial facilities are there to make money with whatever it is they're manufacturing, right? They're not like a municipality that has this deep bench of plant operators. So they don't have the expertise, they don't have the staff and the personnel, and they don't want it. And so that's where our business model is really great. Change in target market. So when Axine got their start, as far as I know, I think we were targeting oil and gas. And then as time went on, it was specialty chemicals. I just looked up in our archive presentations the other day, in like 2015, these are our beachheads. Pharmaceutical was not on that list. And that is absolutely our #1 target right now, is pharmaceutical industry, with PFAS coming up the rear, PFAS and industrial applications. And so, I think, again, whether you're a new company or you're a company that's been around a long time, you've got to be agile, and you've got to be able to recognize, where the opportunity is and really follow the money, the low-hanging fruit, right? So that's been a challenge. And I think you have to be, then once you pick something, you have to be disciplined enough to then stick to it long enough to see, was my hypothesis right? And especially, as you saw on the first slide, whether it's venture capital, private money, or public money, you've got people that you report to, and you tell them what your plan is, and then you've got to see it through. And so that can be absolutely a challenge, but again, it's an opportunity in and of itself. Lack of regulation. The pharmaceutical industry, the active pharmaceutical ingredients in water, pharmaceuticals in the environment, is not regulated at all. It's kind of scary when you think about it. You've probably read about it, or in drinking water. The vast majority of the pharmaceuticals in the environment doesn't actually come from the manufacturing plants directly. It comes from us, right? That we either are disposing of it misproperly, or we're excreting it, right? When we go to the bathroom. And then it goes, through our system, and our current treatment systems aren't handling that. They're not doing anything because they're challenging organics. They're non-biodegradable. So that's a challenge. In the pharmaceutical industry, they're self-regulating right now. It's all voluntary. There's a couple of fantastic, probably even more than that, organizations, but we partner with them very closely. One is the AMR Industry Alliance, Antimicrobial Industry Alliance, and then the other is the PSCI, which is Pharmaceutical Supply Chain Initiative. And both of those are very committed to reducing antimicrobial resistance through the supply chain, through use, and the members are actually very committed to reducing that. And so we work very closely with them, as well as Big Pharma. The other thing is PFAS. PFAS in Europe, has been outlawed for a while now. In the US, we see it state by state a little different. The EPA at the end of last year, announced a roadmap. And just a couple of weeks ago, I think Norman was talking about, I had lunch with a fellow who's at a very big, one of the monsters in the industry, right? And they've got lobbyists on Capitol Hill, and they're actively part of setting the stage for what these regulations are. And someone like someone like me from Exene, first of all, I'm not a degreed engineer. That's not my specialty. I just happen to be in an industry where it's a bunch of engineers. And we're this tiny company in Canada. I don't know that we're getting an invitation to the table, right, to Capitol Hill to talk about what we should do. So to Norman's point, yeah, we have to somehow, we can't all view everybody as competition. We've got to figure out how do we partner together. So we were talking about, could we do pilots together? And that's really a challenge. It's an opportunity, but it's definitely a challenge when you're the little fish, right? But so I think we've got to stay agile, and we've got to keep talking to everybody, right? Doing events like this so that we know what's coming up on the horizon and how we can work together. Other things that have been challenging for us, real-time COD API monitoring, instrumentation. I used to do biological treatment, and instrumentation was always considered like a consumable, like a throwaway. And so having something that's reliable and gives us the value we're looking at and is cost effective is a challenge. But when I was in Vancouver just last month, we had someone in the office from another Canadian company that had some spectrometers. I was on a call recently with another Vancouver company that did some monitoring as well. So thankfully, there's a fantastic network of clean tech companies. And it sounds like everyone does want to work together, and that we do want to, scratch each other's backs, because I think that there is opportunity for some win-win relationships. Almost lastly, and I think probably a lot of you can identify with this, is the electrode cost, the performance, the durability. It's incredibly costly. And the impact of the wastewater characteristics, which are super complex, they're super variable. That impact on that is huge on how the removal rate is, how the rate of electrode erosion is. And so that requires extensive testing, which is both time and high cost. Thankfully, again, we're venture capital backed, and then we've been taking advantage of SDTC grants, NRC, to develop an algorithm or algorithms in a performance software tool that then relates that water chemistry and the material parameters to treatment performance, which then would allow us to take a customer's wastewater properties and quickly determine the expected performance and optimize it, which would then reduce the testing period. So without our relationships, without these grants, I don't really know how we would do this. So we're super fortunate to do that, because again, I remember hearing someone else talking about de-risk. Yeah, if we don't do this, then we've got to over-design to de-risk, right? For us, again, working with pharmaceutical industry, or really any industrial facility, but especially pharmaceuticals, the big pharma companies just have massive targets on their backs on the global stage. And so they're always going to lean towards the lowest risk, but you've got to balance that risk with the design, right? And making it cost effective. And with a performance guarantee, like we already did de-risk it. So yeah, so that's that. Lastly, COVID delays. Again, I'm new enough with Exene that, COVID's not totally over, but things are a lot more opened up than early on. But my understanding is, we've wanted to do pilots in Europe, and COVID, with the restrictions and all of that, made it impossible for us to carry those out. And then we were trying to use the CAN export program. And I know that that's on my radar of things that I need to do. And I've been talking with the Trade Commissioner's office about that program to support, not only from a technology standpoint, but also from a commercial standpoint, and helping us travel to these different places around the world. We're very focused on all of the Americas and Europe at this point, but we absolutely plan to take more advantage of that program. And that is what I've got, if anyone has any questions.
Okay, thanks for that, Krista.
Yeah.
really great summary, and I think you hit on, as you noted, you hit on a few points that were common throughout, kind of that idea of collaboration, and we're hearing pretty strong from all of our presenters and from our panel that idea of working together and collaborating being so key to innovation. So thanks for that. And just looking at the time, I'd like to transition into closing here. And if anyone has a question for Krista or for Dr. Roberts, please go to the chat and or reach out directly. We'll provide that contact information. So with that, I'd like to thank all of our presenters again, and I'm going to bring our panelists back for a quick closing thought before we finalize the session here. So JC, I know you had an example you wanted to share that kind of ties some knots together here. So we'll pass it to you, JC, for that thought on collaboration, and then over to Kevin to close out on Aqua.
Yeah, thanks, Steve. Appreciate that. So yeah, Krista mentioned a number of things about, the challenges with the electrode design. And I mentioned really early on the challenges in the industry around having, softening, which is a challenging process to operate. So we're looking to do something different in the industry. And ties together with the WTDC and why we're doing that. And so really, and also Ted Roberts' presentation and also Sean's presentation. So way back when, about in 2016, when I was in my Shell days, we started looking at new technologies to consider, and EC came up. I didn't know a whole lot about it, but Ted, or Dr. Roberts, I should say, sorry, Ted, had come to COSIA, actually another collaboration innovation group, and presented to us. And so we got excited about that, and we ended up learning a lot more about it through that work. And then actually did a small pilot. It didn't work out quite so well because we realized we didn't really understand the technology very well. So then we moved on and started talking to other vendors. And so we ended up collaborating with Ground Effects on that, and Sean's company, and also with Dr. Roberts in terms of doing fundamentals research. And that was some of the work that Dr. Roberts presented earlier. So it was a real, it was understanding how we can make a highly tunable process, as Sean mentioned, work in oil and gas and maybe replace our incumbent technology. And so that was a really interesting, I guess, potentially lucrative way to go with our water treatment technologies in situ. And so we started working with Ground Effects as well. And we started the three of us started collaborating together, and we started working on ways to incorporate some of the stuff that maybe Dr. Roberts is coming up with in his research into actual equipment. And likewise, some of the needs that we had within industry of treating at higher temperatures and pressures into vendor offerings. So that collaboration ended up, and it's still going on today. In fact, we just had a workshop yesterday. So it's been really good, and I think it's hopefully steering the development of the technology. And I just wanted to highlight that as a real shining example of how this collaboration working together can actually between academia and industry can really result in developments in technology and potential adoption.
Yeah, thanks, JC. That's a great way to kind of tie up some threads here of all the speakers and the way they're collaborating. Kevin, I do want to pass to you quickly for your thoughts on collaboration at Aqua, and then we'll pass to Adele to close.
Thanks, Steve. Yeah, I'll keep my comments really brief, but I'm going to echo what JC said. Do something different, and if you're interested in engaging with Aqua to try something, I'll drop my email address in the chat. We can provide services, cost recovery on a cost recovery basis to industry and municipalities, both technology developers and technology end users, for everything from wastewater characterization through bench scale, both treatability studies and sort of very small scale treatment systems, all the way through to pilots. And as JC mentioned at the beginning, we're working on potentially working more firmly with WTDC. So this may be a proving ground for you as well.
Okay, awesome. Thanks for that, Kevin. So Adele, over to you to close things out. And sorry, we didn't give much time for that, but over to you.
All good, Steve. Thank you. Thank you to all our presenters, our panelists. This was a really great discussion. I hope it sparked a lot of ideas in our attendees. And my call to action to everyone here is, if you're not already a CRIN member, please go to the cleanresourceinnovation.com website to join. It is free to become a member. And I do want to add, one of the huge benefits of joining CRIN is that if any producer decides to pilot your technology, this automatically de-risks it for financial groups such as venture capitalists, angel investors, along with the BDC. You saw Krista present, and I saw the BDC logo there on her opening slide. So definitely, something there for to support your technology so that it lasts through that very long development journey. Also, the Trade Commissioner Service and other government partners are 100% committed to supporting clean tech companies. And so CRIN is a really powerful resource for you innovators out there that are, trying to stay in the game and make your technologies visible to industry. So please reach out, connect with us through LinkedIn, reach out to myself, Mick, anyone that you saw here today. We're all here to accelerate technology adoption. And if we work together, we can get there faster. So thanks, everyone. And we look forward to seeing you at our future events. And please be sure to fill out the survey so we can make these events even better. Thank you so much. And thank you, Steve, for moderating today.
Great. Yeah, thanks, everyone.
Thanks, Steve.
Okay, thank you, everybody. Take care.